Hello everyone, my name is Ryan from the University of Tasmania and welcome to our afternoon session on our engineering program. This is mainly for those of you who are considering studying with us next year or in the future, and we have a lot of information to get through this afternoon, so thank you for joining us. We'll get cracking. Before we essentially get into things, I'd like to take a moment to acknowledge the traditional owners of the land across all of the places you're joining us from. Here at the University of Tasmania, it's often the Palawa and Pakana people that you'll be considering, and respecting Indigenous knowledge and perspectives is something that we are really committed to here at the university, and something that you'll see throughout your time with us, really. I would like to recognise the Aboriginal history and culture of the land and acknowledge and pay respect to the traditional owners and to elders past, present and emerging of the land in which we stand on today, and all the land of the University of Tasmanian campuses, and obviously from wherever you're joining us as well this afternoon. So is it exactly that we're going to cover this afternoon? So the first thing we're going to go through is a little bit about the University of Tasmania. A lot of you are probably already familiar with us, but we like to just cover a little bit about why it is you should study with us. What is it exactly that makes us unique as a university? We're going to go through our engineering program, our Bachelor of Engineering, so talking about the specializations, the disciplines that are offered as part of that program. We're going to also talk about part of the way our program has been revamped, which is essentially a world first sort of leading the way program, and we're really excited to chat about that as well. We're going to go through some fee and scholarship information, how to apply if you haven't already applied with us. We're going to have a bit of information about applying as an international student, and we'll definitely have time to have a Q&A as well. So if you have questions, please make sure to set them aside. We'll run through the questions essentially as we go. So you can see here at the bottom of your screen, there's a Q&A button. My colleague Dougal is online at the moment, and he'll be answering questions as we go. If there are questions that you have, just pop them in. If we can't answer them as we're going, we'll do a live Q&A at the end. So there's plenty of opportunity to ask all the burning questions that you have. And also at the end of the webinar, you're going to be prompted to share a little bit of feedback on your experience this afternoon through a quick survey. And we really appreciate you guys filling that out just to help us improve these webinars. We want to make sure that you're using your time efficiently, and we're making sure that you're getting all the information that you need in the session. So before we get into talking about why it is you're here, our engineering program, I'd like to just talk a little bit about the university as a whole. We have a few different statistics here, and I know statistics isn't everyone's cup of tea, but I just wanted to put it together, I guess, just as a little bit of a snapshot of what the university is all about. And I think these four really highlight exactly what it is we're all about as a university. So we have 81% satisfaction rate with our teaching quality and engagement. It's on par with the national average, which we're really proud of. It's not an easy statistic to keep up, so we're really proud of that one. We also have excellent graduate outcomes. So we have an 85% full-time employment rate 4 months after graduation compared to the national average of 80%. So we're up on most other universities, which we're very proud of as well, especially being a small state. We also have really strong student support. So either whether you're looking at the academic side of things where you might need help, or other support that you might need in other aspects of your life, there's always someone here to help. And I'll go through that a little bit in more detail a little bit after we've heard about the main reason you're here, which is the engineering program. But lastly, that statistic is that we're #1 in the world for climate action. This comes from the Times Higher Education Impact Rankings, and essentially it looks at everything we do as a university, including what it is that we teach, the way we teach it, the research we do, the environmental impact of everything that we do as a university, including things like our physical teaching spaces, the resources that we use to teach students. We do have a really genuine commitment to sustainability, and it's at the center of all the things that we do. And to be awarded that for the last 4 years in a row, we are very proud of that one. So we sing that one from the rooftops. Now let's get into things. Today we have Professor Tim Finnegan. He is our head of school at engineering. He has a plethora of experience to be leading this program. Essentially, he is currently our head, but prior to joining the university, he was the director of CSIRO Energy, where he led over 450 scientists, engineers, economists, and business professionals involved in research to enable Australia's transition to a net zero emissions energy future. He has a wealth of experience before that role as well, and so we are really, really lucky to have Tim on board, leading our engineering program. And honestly, people that go into this program should be really excited with what it is that he is creating in the School of Engineering as well. So, Tim, thank you so much for joining us. If you want to take it away, please do so.
Yeah, thanks, Ryan, and good afternoon, everyone. Really looking forward to having a bit of a chat. If you just think about the image you saw on the page before, maybe you can flick back for a second if we're controlling the slides.
No problem.
Yeah. Just to lead in, tell you a bit more about myself and my experience as an engineer, because in order to tell you about engineering and suggest to you that it's a great career path, I only know it from my own experience with it. And I chose engineering myself at one point some years ago. And I chose engineering to study because when I was in school, I liked maths and kind of like physics, and chemistry was okay. I didn't mind some of the other subjects, but those are the ones that sort of held my interest. I didn't really know once I started university too much about engineering. Of course, I knew what science was, sort of, and I kind of knew what physics was. And I kind of started down that path, but quickly realized that science is wonderful. I love science, but what I really wanted to do was have impact and build things and create new things. So engineering provided a pathway for me to use those maths and science skills, but really apply them in a practical way to create tangible, real life things in the world. And so the picture you see on the right there, I wonder if you can guess what that is, dangling there above the sea. Probably haven't seen something like that at all, because it's a unique thing. It's never been done anywhere. Something I invented, called BioWave. It's actually an ocean wave energy conversion device. So this is a 7-story high machine that gets placed in the ocean and moves under the forces of the ocean waves and swell, and converts that motion into electricity for use onshore as clean energy. It's a new and emerging experimental area, but this is engineering. So this is taking scientific principles and using it to innovate and do new things, to try to create solutions for society. And one of my passions or my interest is in coming up with zero emissions and clean energy technology. So this is one project I worked on for some time, and I thought I'd just show it there as an example. So let's keep moving. Next slide. Okay, I'll tell you about the Bachelor of Engineering with honors. And so you're aware, the bachelor's degree in engineering, wherever you earn one, wherever you achieve that credential, is really the gateway to professional engineering. And professional engineering is sort of a distinction from general engineering in the workforce. You can have someone who is sort of a technician or a tradesperson. Sometimes they'll call themselves an engineer. But a professional engineer is a degree qualified engineer. And by qualifying with a degree, you take on certain liabilities and responsibilities in society. So think about all the things around you in the world. Looking at the picture, the wind turbines, the power system that feeds energy to our houses. Think about the bridges and the buildings. You can think about all the factories and machines and electric vehicles, and pretty much everything that we interact with in our day-to-day lives are engineered. And it's professional engineers, degree qualified engineers, that have the responsibility for developing, designing, testing, and maintaining those systems. They are professional because when those things break down, or they don't work, or they're not designed properly, it's the engineer's responsibility. So if you compare it to, say, a doctor, you'd want your doctor, if they're going to do an operation on someone, to be very well qualified in doing that. It's the same with engineering. If you want someone to design an airplane or a bridge, you want them to be very well qualified in that design. And that's what an engineering degree, a Bachelor of Engineering, provides for you. So the degree is 4 years in duration. And at UTAS, the engineering degrees are taken at the Sandy Bay campus. We do have marine engineering available through the AMC Advanced system, but I'm here representing the engineering school that's based at Sandy Bay, where we offer the specializations you'll see listed below in civil engineering, electrical engineering, and mechanical engineering. And I'll tell you a bit more about each of those in the slides coming up. So just jumping up, you see some information there on entry requirements, and you can read the basic prerequisites that you would be required to have for entry. And of course, if you have questions, we can talk more about those, give you some more specific information. Now, if you lack one of those and you still want to join the engineering degree, please reach out to our team, because there are some short bridging courses that you can enroll in. For example, if you didn't have maths methods, we have a summer course you can take, and it will give you the equivalent maths requirements to enter into the degree before semester starts. So be aware that if you've got these and you're tracking well to achieve them, then you'll be eligible for entry. If you don't, there's still ways. There's still other ways you can still get the requirements to enter. Now, the accreditation at the bottom there relates to what I was saying about the important credentials that a professional engineer acquires. So it is a regulated environment in that not anybody can just design a bridge. You can't say, no, I'm pretty good at engineering, let me design the bridge. There are laws that require certain types of systems and infrastructure that require an engineer to officially approve those designs before they're built. And it's regulated across the country. Now, the ticket to be able to do that is the Bachelor of Engineering degree. The same thing happens in most other countries around the world. So you might be wondering, well, what if I got my Bachelor of Engineering degree at UTAS and I decided to go work in England or France or Japan or somewhere? Well, our degree, being accredited by the industry body Engineers Australia under something called the Washington Accord, it's an agreement across 32 other countries that will say that if you take your degree from UTAS to any of those countries, it's immediately recognized as equivalent to their professional engineering degree in that country. No exams, no extra screening or anything. You could walk into an engineering office in France, for example, and they'll say, oh, Washington Accord, good, you're good to go. You can start designing the bridge here in France. So that's the power of this degree. You might pick up that I have got a little bit of an accent. I earned my first degree in Canada. It's also a signatory to the Washington Accord. So when I came to Australia, eventually presented my Canadian engineering degree. No problem. You're under the Washington Accord. It's equivalent to an Australian engineering degree. So that's the portability of this qualification. Next slide, please. Now, the climate safe approach to engineering is a new development that we are pioneering at UTAS. Our degree covers industry endorsed standard engineering fit for developing all the systems that I just described. If you take civil engineering, mechanical, or electrical engineering, you will have all the credentials and skills and capabilities of any engineer that's educated at any university. However, just like Ryan was saying, at UTAS, we are number one in the world in climate action. And when you think about engineering, 80% of the world's carbon emissions are from industries that have some direct connection with engineering. So engineers actually have a big impact on the environment and on climate. For example, think about concrete. concrete is made from cement. Cement, the production of cement creates 8% of the world's carbon emissions. So what we're doing at UTAS is we're saying, we will teach you civil engineering if you chose that discipline. You will be trained in the design of structures, building materials, and very modern approaches to that practice. But we will also teach you how to assess the carbon impacts of those types of structures and how to look for alternatives, perhaps better ways to design certain structures to reduce those emissions. That's what climate safe engineering is. It's also looking at hazards as the climate increasingly becomes a little less stable. We need to design our future engineered infrastructure to manage the impacts of, say, higher winds or more intense rainfall. We will embed that information into our engineering approach so that as you go forward into the future, and an engineering career is a long career, it'd be decades potentially as an engineer, you will have all the skill sets to deal with the climate impacts as we move forward through engineering. So climate safe, as I said, has two aspects to it. One is the mitigation. And mitigation just means slowing down climate change before it gets worse. So let's cut all the emissions from what we're doing. Just like I said with the concrete, the combustion of fossil fuels, coal and oil and gas. If we can find better ways to do those things, then we slow down climate change. So that's the mitigation side across the top. And the types of things we look at to do that are renewable energy, energy storage, electrification, hydrogen, things like that. Looking at timber rather than cement as an alternative building material, that's cutting down the emissions that are released. We can't stop everything, and we already know that we're dealing with certain hazards that are increased or enhanced by climate change. They're happening already. Bushfires, forest floods, heat waves, and the like. We need to design for those. So the other side of climate safe engineering is looking at all those hazards and designing our infrastructure and systems to deal with them better. And as I said, these elements, these examples, the case studies, the design approaches, and the awareness of these aspects are embedded throughout the UTAS engineering degree program. Next slide, please. So now we come to the different specializations within the bachelor's degree of engineering. And let's start with civil engineering. So think of the term civil. You ask, what does civil mean? Well, civilization, civilian, certain words start with the word civil, and it really means society and everything around us. So civil engineers design all the big stuff typically around us. I'm a civil engineer, and I showed you in my opening an example of a power plant based in the ocean. Well, that's a piece of civil infrastructure because it provides a useful benefit to society. So bridges, coastline protection, roads, buildings, waste treatment plants, seawalls, waterways, all these things are designed and developed by civil engineers. You can see there. So it's an exciting career. I've been working in civil engineering for many years myself and absolutely enjoyed every minute of it. So I can guarantee if you're looking for challenges and excitement and interesting things to spend your life working on in your career, civil engineering is a great option. Next slide, please. Electrical engineering, equally exciting and interesting. And if you think of electrical engineering, it spans a large range of scales. So pick up your mobile phone, inside it are electronic components, right down to semiconductors and microelectronic chips and things like that. Electrical engineers design those systems, how they interact on the circuit board, how they work with software, and how they provide what the user needs. So that's right down at the small scale of electrical engineering, moving into the realm of electronics engineering, which is part of our course. And you can specialize more in that area by choosing certain electives within the course. Now go all the way up to the big end of the scale, to the massive power plants, the hydro systems that we have, particularly in Tasmania, the huge dams that hold the water back so that we can drain it through a turbine and create electricity when we need it. So electrical engineering is all about designing and developing the systems that we need to produce power and to produce devices and things. It's a really fascinating area because it's changing so fast. We're moving from an old type of engineering to renewable energy, solar panels with batteries, electric vehicles, all working together in the grid to create the energy we need. And at UTAS, we're very strong in this area. We're at the cutting edge of applying these methods in our degree. So our graduates in electrical engineering come out and are immediately useful and very employable in this exciting and fast-moving area. So that's electrical engineering. Next, we have mechanical engineering. And think about all the different mechanisms. Take one that's very familiar to us all, a vehicle, a car. So somebody designs the car, how it works, what's inside, all the moving parts, all the gears and mechanisms. Engineers develop and design those systems, all the way through to mining equipment, processing plants, the factories and machines that create all the things we use in our lives are all designed and developed by mechanical engineering. Think about the building you're in at the moment, wherever you may be, the heating and cooling systems, all developed by mechanical engineers. And of course, with the climate safe approach, we're looking at ways to make all these systems more efficient, more cost effective, lower impact on the environment, and zero emissions. Okay, so mechanical engineering, again, back to the example I showed you in my opening, that system is a large civil infrastructure, but it was basically a 600-ton robot full of mechanical systems. It also had electric systems. So you can imagine I was, myself personally, fascinated by the whole project because it combined all three of these types of engineering, which I found and still do find very satisfying to work with other types of engineers on systems that combine the disciplines. Okay, so those are the three disciplines, or we call them specializations, that you would choose between in the engineering degree. And we'll go a little bit further to how they fit into the degree structure. So next slide, please. But first, we'll talk about the prime program. So at UTAS, we're quite fortunate. It's a relatively small department compared to, say, some of the very large city engineering programs, which have thousands of engineering students. Here, we don't have thousands of students, so we can get really close to hands-on instruction and training for our students that allows them to also interact with industry. So that primed acronym, Profession Ready Industry Merged Engineering Degree, refers to a systematic process where we have real engineers from companies, from out there working in power plants and factories and design offices. They actually come in to the university and work with our professors to help convey to you, to our students learning, what it's really like to be an engineer. So one thing is to be taught the theory and the skills by the academic staff, but we also want to have students learn about the real life application of those methods once we graduate. And we have industry people to come in and give our students that real life experience. So also by the time you finish your fourth year, you all already know what engineering in practice is like because you've been seeing it through the degree. And also every student gets to know people from industry. So it all opens up a lot of opportunities for employment and jobs. And here we have a range of companies that are signed up to our program. So all of these would have engagement in the degree, and you would have opportunities to meet people and learn from them and potentially gain employment. So next, please.
That's all the slides we have, Tim. But
Okay, yeah.
I just have a question I think might be relevant just since we're on the topic of all the different disciplines that we have. What would you say to someone that's looking at all these different disciplines and all these different specialist areas? Like, how does someone narrow down what is going to be right for them?
Yeah, okay. So when you start the first year, it's common. So every student that comes into first year will all study the same subjects in first year. And we've got three subjects in first year, which we're calling the foundation subjects. One is called Civil Engineering Foundations, one is Mechanical Engineering Foundations, and Electrical Engineering Foundations. So regardless of which degree you ultimately choose, in the first year, everyone will get a full understanding of what each of those three main specializations are. So I'll repeat them again: civil engineering, mechanical engineering, electrical engineering. When you finish the first year, you choose one of the three to complete your degree, and you qualify at the end with a degree in that discipline. But having the first year common, you'll get a very good understanding of what each of those specializations are about, so you can make an informed choice of which one you like best.
Awesome. That's really, really helpful. Is there anything else you'd like to add before we move on to some of the more admin things that we have to go through today?
No, it was the right question, because when I was saying I'll talk
Yeah.
about how the structure works, it's exactly to share that feature that the first year should give everyone a broad base of understanding, and also those skills once you're out working. It's always good, as I have done, and that all engineers do, is I think back to the electrical engineering I learned in my first and second year, and it comes in handy as a civil engineer once in a while when someone raises a topic that's related to that.
That's amazing. Thank you so much. Look, Tim's going to hang around you guys to have a bit more of a chat if there's any more specific questions around the program. But thank you so much, Tim. It's very interesting and exciting to see what it is that we're doing in the School of Engineering at the moment. What we're going to move on to at the moment, everyone, is just a little bit more of the admin side, I guess, or just a bit more about what it is to like to study with us. So like I said, we do have time dedicated to Q&A with Tim at the end. And if you have any questions as we're going, please pop them in the chat function. But before we get to those questions, I really just wanted to talk a little bit about some of the support that we do provide to our students, because we do make a point to offer a wide area support that covers a lot of different areas and I guess aspects of your study experience. When you come and study with us at UTAS, you are there to get a qualification and I guess enhance your education. And a lot of the time that's individual to the person, whether it's just a study journey or whether they have to tick a box to get a qualification to work in a certain industry. But no matter what it is that you're doing when you're studying with us, you're not just a student. That we know that there are a lot of other things that are going on in people's lives, whether you have children, whether you're working part-time or full-time at the same time as studying with us. A lot of different people come and study with us, and we try to offer, I guess, support across a range of areas. So when we look at like the study support space, I suppose you could say, some of the options are available are listed there. I'll just highlight a couple. So we've got something called PASS, which is a peer-assisted study session. Those are essentially casual study sessions led by current students who might only be 1 or 2 years ahead of you, but the whole idea of it is that they've completed the units that you'll be currently doing, and they're able to help you with all the tips and tricks that you may have learned, that they may have learned through their own experience. So those sessions are really, really valuable. They know the pain points as students already, they've been through the process. The second one I want to highlight is our student advisory team. So student advisors we have at UTAS, it's a really, really important place for you to go as a student when you start with us. They can help with things like enrolling in your subjects, how do you plan your study, how do you make a timetable to suit you best, and they can connect you with all of the other student support services. So if there's one thing for support that you take away, it's to connect with the student advisory team. I'd say they're kind of like a compass for navigating university, particularly when you first start with us. But as you go through uni, you can always go back to them as well for further assistance. You definitely also have access to learning workshops. We have a 24-hour study support platform, which is called Studio City. That's pretty cool. You can submit draft assignments. You get given feedback. You can chat online with subject matter experts. That's really handy. Career services, obviously pretty important if you're studying a degree and then you're going to have to go out and find a job after that. Or even while you are studying with us, there's student job boards. You can register if you want to do volunteer work, or potentially you might want to find some experience through your program as well. Our Careers Connect team is really amazing. They actually help you with career planning, resume development. They even do mock interviews. So I'd highly recommend to connect with them when you do get to university as well. And I guess the last part, like I mentioned before, everyone that's studying with us, study is just an aspect of your life. There's a lot of other things that go on in everyone's life. And so we offer a wide range of counselling and wellbeing services. As a student, you can actually access these for free. They're confidential, professional counselling. You can do them in person, you can do them online for those of you who are studying online. And essentially, you can seek that support if you're experiencing issues in any aspect of your life at all. We try to make that available and as flexible as possible for you and for all of our students, just to make sure there's enough support that's on offer. Now over to a little bit of information, I guess, about like the nitty-gritty of applying and things like that. I know some of you have already applied and probably already have offers that are here this afternoon. But for those of you who don't, there is a bit more information in here as well. The first thing I just want to highlight is, I guess, a cost of a degree. So it's a question we get asked all the time from students, University, unfortunately, it's not free, but we do have an amazing system in Australia where all of our courses are offered under a Commonwealth supported place. If you're not familiar with that, that's totally fine. There's a bit of jargon in it. But essentially what it means is that if you study at a university in Australia, you can defer your fees onto the government. Once you start earning over $54,000 a year, you'll start paying it back incrementally through your tax. So it's a really amazing way actually to access higher education, and we are very, very lucky to have that system in Australia. You'll see there at the top, you also have what's called a student services and amenities fee. So that is roughly $350 a year. We do cap that. You can defer that onto your help loan as well. That's something that we can give you support in paying. If you can't pay that up front, that's totally fine. But what that does essentially is it helps things like servicing the campus, offering things like free counselling, all that kind of thing. It's there for students to essentially have access to a range of things across the university whilst you're studying with us. We also have many different scholarships. So I'd like to say hundreds. I think there's over 400 scholarships available, which, they can be awarded depending on who you are as a person. So honestly, we have academic scholarships. You can have community involvement scholarships, equity scholarships, diversity scholarships, sporting achievement. We have what's called a relocation support to study package. So if you are moving more than 50 kilometres to any of the UTAS campuses, we do offer a payment for that as well. So that's to help you, like it is titled, support to study. That's to help you move to study with us. So one thing that's really, really important is those scholarship applications do close at the end of this month. It's a very easy application if you haven't looked yet. You just go to our scholarships portal on our website and you log in, make a profile. You can apply for many different scholarships at one time. So if there's 4 or 5 scholarships that you're interested in, you can absolutely just make one application that'll cover you for all of those. So please make sure to have a look at that because there is actually quite a lot of funding available. If you haven't actually already applied for a course with us, like engineering, you can jump onto our website and follow the step-by-step process. It's very quick and easy. It shouldn't take you longer than 15 minutes, honestly. If you're a current Year 12 student and you're here today and you haven't applied for our early entry program, which is called the Schools Recommendation Program, you can absolutely still apply with us, so don't worry about that too much at all. And essentially what will happen is when your Year 12 results come out at the end of the year, usually in December, mid-December, then we'll use that to assess you for an offer. So if you miss the early entry, do not worry about that at all. There's definitely still time to make an application. If you do apply with us, or you already have and you've got an offer, or you do get an offer in the future, essentially what will happen is you'll be asked to accept the offer in our application portal. What this does is it really lets us know that you want a place in the course, so we can plan ahead for the following year. After that, you'll do an enrollment process. When you can enroll does depend a little bit on who you are and where you're coming from. So if you're in Year 12 at the moment, your enrollment won't open until you finish Year 12 and your results have been released. And good luck to those of you who are going through Year 12 at the moment. Are you almost there? And if you're not in Year 12, enrollments for 2026 will be opening in November. So you definitely have plenty of time to do that. And they usually open until the first week of semester 1. So plenty of time for enrollment. I'm just going to hand over to Patrick, who's joining us today. We usually have international students who join us, so hopefully there are a few of you in the room. So Patrick, please let us know how you can apply if you're an international student.
Yeah, sure. Hi guys, I'm Patrick. I'm joining on behalf of the international recruitment team. So basically the application for international student is pretty similar to the domestic one. So I don't repeat too much about how to get an offer. And however, from where you can locate the apply button is basically when you select the course you want to apply. And on the top right-hand side, you can click apply now, and it will redirect you to the online application portal. And we streamline our online application portal where it should be pretty straightforward and accessible for students to follow the step and upload all the documents and previous qualification and then submit the application for the offers. We aim to assess the application within a week, but sometimes it may take longer to get the offer released. For the scholarship for 2026 semester 1 entry, we have 2 major scholarships that's available for international students. The first one would be the early acceptance scholarship. What it means by that is as long as you accept the offer by the certain time frame of the that lists on your offer letter, you will automatically get the 15% off from the whole cost of your studies. And then the other one we call Tasmania International Scholarship, and this one is a merit-based scholarship where you can get 25% off from your study. And however, this one would need to be based on your previous qualification and your academic performance. And again, both scholarship, you don't need to submit a separate application. You will automatically assess once you submit the course application with us. And also for the fees information, you can basically check on our course webpage by selecting the international tab. And then you can see there's a section called fees and course stuff, and then where you can see each of the international fees for each courses. And also, if you would like to speak with our team member, our international team member, feel free to visit the website that lists in here, like the utas.edu/study/international/contact. So you can book a online Zoom meeting or a Teams meeting with us. Also, you can always email us if you have any question about the academic entry or anything you would like to get more information. And we aim to reply within 3 days. Thank you.
Awesome. Thank you, Patrick. I know when I have international students come to me and I know nothing about the international space, you guys are super helpful. So thank you very much for that. We've wrapped up the main portion of, I guess you could say, the webinar information today. So we're just going to move on. I'm going to stop sharing my screen. If anyone has any questions, looks like Dougal has one, then we can go ahead with that.
Hi, Tim. I think this one's for you to answer. We just got some asking. They've read somewhere on the UTAS website that for the degree that the AI will play a role in the degree, and they're wondering to what extent they'll learn and how it compares to other potential AI systems that companies use. I think
that
just
might make
asking about how the AI, if AI is a part of this, is a part of the Bachelor of Engineering, I guess.
Absolutely. Yeah, AI is a part of it because AI is part of our world and part of our lives. And yeah, and we will be using AI. We are using AI, and AI is part of engineering. It is used in the engineering sector in companies and private sector. So as our degree, as you move through the degree, you will learn the AI skills you need to operate effectively in the engineering profession. So there's a whole range of different aspects of AI. So there's the ChatGPT large language model type AI that's very common, and people are using it now to search things on the web and to write emails and to, create documents and summarize things. Yes, that's integrated and is applied appropriately within different subjects to make your study more efficient and give you some training in how that will be used in the profession. But then there's the old or the other type of AI, which is machine learning and all the things that are used for, say, self-driving cars and automation of factory systems and that sort of thing. We also integrate that where needed in our detailed technical subjects to use AI to develop engineering know-how and systems in the same way it's used in the profession. So yeah, unlikely you'll go through the degree and not have some pretty strong connection with AI applications.
Thanks, Tim.
That's really interesting, I think, because it sounds like you're kind of just going with it, if you know what I mean, because we have to, we have to embrace it, like you said. I've heard different other universities not necessarily have the same kind of open approach with it. So I think that's really interesting that's a great question, honestly. I've had another one here. Tim, do you have any idea of any of the most popular subjects or units in our degree that maybe pique some students' interests that might be a bit interesting?
Well, my obvious answer is they're all interesting, of course. But I think the way I'll answer that is the first year gives you a really great taste of everything in engineering. We've also got, so I mentioned earlier the foundational subjects in first year, civil, mechanical, and electrical engineering. There's also mathematics unit, which is very popular. Students really love that one. And then in the curriculum, there's a climate safe set of subjects in the first year, which covers a number of things. So it teaches things like the science behind climate change, but it also talks and gives students skills in communications and the human side, the social side of engineering, which is really important. So, engineers are a spectrum. Everyone's different. Everyone has a different approach to how they want to take their engineering career. Some love the very mathematical, technical side of things. Others like the more humanitarian and social side of things. And our degree is flexible enough to cater to the whole range. Not all engineering is about equations and maths. It's largely about people, and we teach the human and people side of engineering as well. So I don't know, the interesting subjects as you move out the years. Of course, the subjects that you study become more and more specialized. Say, now I'll just use an example in mechanical engineering. If you choose that pathway, you'll end up in a subject called advanced vibrations and control. So mechanical systems, if you think of ships or engines, airplane wings, when things get moving in engineering, sometimes you get vibrations and things. Well, engineers pick all that stuff apart, apply equations and analysis techniques, AI sometimes, to understand those types of responses and then feed it back into the design process so that vibrations don't cause problems in the operation of that equipment. Once you get up into those levels, it's absolutely fascinating as you start to explore the details of engineering. And there's similar interesting specialized topics in electrical and in civil.
That's awesome. You're clearly very passionate, which I hope you would be as the head of our School of Engineering, but you absolutely are. And I really like what you said actually about, you know, engineers are all different types of people, because I do think that there is a very strong stereotype about what engineers are like, but it really goes to show that you can have a lot of different skill sets and still kind of come into that industry and really do well, which I think is amazing. You know, it sounds kind of inclusive, which is nice as well.
Absolutely. If you if you Google engineering or engineer, and I suggest you don't do that, because quite likely what you'll see is a photo of typically a man with a high-vis vest and a hard hat. That is just one small part of engineering. That's not all engineering. Engineering is such a broad discipline that you can find yourself working in any environment. So, for example, I rarely ever put on a hard hat. It's only when I visit a hazardous site or something. And most of the time I've spent in business offices or consulting firms, or out in the field as well, doing testing on things. And we want to have our engineering school equally accessible and comfortable for everyone, men, women, and all different backgrounds and all different people, because it really is a profession for all.
Awesome, thank you. That's probably a good segue actually. Just to kind of round out the webinar today, for those of you who haven't visited us or visited any of our campuses, please make sure to do so if you are really considering coming to Tassie, or you live in Tasmania and you're going to be coming along to one of our campuses to study. Please make sure that you do visit our campuses, make a booking or come along to one of our events. We'd absolutely love to chat with you in person. It's the best way, honestly, to get a feel for what the university is like and what it is we are about at the University of Tasmania. I can't see any other questions there in the chat, but Dougal will post the link to our contact page on our website. Thank you, Dougal. So if you do have any more questions, please make sure to reach out to us. The team is available, Monday to Friday, 9 to 5. We're always happy to help. And I just want to say thank you so much for joining us this afternoon. We really appreciate it. And thank you, Tim, so much for taking us through the ins and outs of the program. Thank you so much. Have a good afternoon, everyone. Oh, Dougal, you have a question.
Sorry, I can't post that. I don't, but if you've got any questions, it's future.students@utas.edu.au. We will also be sending you an email in like a week or so within the week that will have the recording of the webinar and also some other contact links on it as well, so you can contact with us that way.
Thank you, Dougal. Thank you, everyone. Have a nice afternoon.